dissect it and examine it a little bit more closely. You'll notice that the number of workers and the total number of lawns is identical to what we saw on the previous slide. The only difference here is adding the concepts of marginal product and average product to our table. Marginal product, remember, is the addition of one more worker, the impact of that one more worker on the number of goods produced. So when we add the first worker, they add 10 more products, 10 more lawns, than having 0 workers. So therefore, the marginal product of the first worker is 10 lawns. The second worker added 15 mowed lawns, bringing the total up to 25. The difference between 25 and 10 is 15. The third worker added 10. The fourth worker added 5. And the fifth worker only added 2 goods. So we can see here, by looking at this data, that the law of diminishing marginal returns sets in with the third worker, because this is the first point where the marginal productivity has decreased compared to the previous worker. Lastly, we want to take a look at the concept of average product. Average product is telling us what a typical worker makes within a group of workers. So, for example, while the third worker produces 10 goods and 3 workers produce 35 goods, the typical worker, when 3 workers are employed, are going to produce 11.67 goods, 11 2/3. And that's arrived at by taking the total number of goods produced and dividing it by the number of workers that produced those goods. So we can see that the average product rises and then falls as a result of the diminishing marginal productivity of the workers. What we'd like to take a look at next then is graphing these 3 columns, the total product column, the marginal product column, and the average product column on the same set of axes, and we'll see that on our next slide. Here we see the productivity of workers measured in the number of goods produced versus the number of workers that are producing them. And we're taking a look at our 3 measures, the total product, the marginal product, and the average product. And graphing these allows us to take a closer examination and see the interrelation between these concepts. So for example, we notice that the total product increases at an increasing rate and then begins to increase at a decreasing rate and begins to slow down. Eventually, we actually might see the total product decrease after a certain point. And we can find those points relative to the marginal product column. So the marginal product is the addition from one more worker. And we can see here that when diminishing marginal return sets in, that is with the third worker, the marginal productivity has decreased. And that is instructive to us because we see on the total product column an inflection point at this point. To this point, total product has been increasing at an increasing rate. It's been going faster and faster. And then, because each additional worker is adding less and less, the total product begins to go up by that lesser and lesser amount. It's still increasing because marginal product is greater than 0, but it is increasing at a decreasing rate. If the marginal product ever becomes negative, that will in turn make the total product begin to decrease. For those of you who are interested, we can simply state that the marginal product is the derivative of the total product. That is, it is the slope. So when the marginal product is 0, the slope of the total product is 0, which means that the next worker added would decrease total production. One other thing worth noting on this is the relationship between the average and the marginal. Notice that whenever the marginal is greater than the average is sloping upwards. Once the marginal becomes less than the average begins to slope downwards. This is an important concept not only in productivity, but later we'll see in costs as well. The relationship between the marginal and the average is instructive. You do this all the time though. In any given class, you can calculate your class average by taking a look at the total number of tests you've taken and the scores that you've received on those tests. So for example, if your class average is an 80 and your next test is a 90, then we all know that the average must rise. So that all that's saying is that when the marginal is greater than the average must be increasing. However, if your average is an 85 and you get an 80 on the next test, then your average grade is in excess of your marginal grade, and so your marginal grade is pulling the average down. So your grade average would decrease from that 85 with a test average, with your marginal test rather, of an 80.